All right, so endocrine system. We started talking about it a little bit last time, and I told you that one thing that will show up on the next test is a diagram. So you need to be able to label where all the glands are. Remember, you got 3 in the brain that are important. It's kind of hard to tell which one's which. So I'll go to a slightly better diagram. The one in blue in this diagram is the hypothalamus. And that's sort of, remember, like the boss of the endocrine system. It's all about homeostasis. It's monitoring things. And if it figures out that something is not right, the cool thing about the hypothalamus is it's really in charge of 2 systems in one way or another. It can send out endocrine systems, so it can send out hormones. Or what else can it send out? Electrical signals, because it's part of the brain. And it can fix lots of problems because it's part of 2 systems. Just below it in red is the pituitary. It looks like a little peanut. It's sort of second in command in the endocrine system. And then more toward the back, middle, the part that's sort of right here in green, is the pineal gland. And that one is in charge of controlling what kind of thing?
Circadian rhythms.
Yeah, your circadian rhythms, like your biorhythms, your sleep-wake kinds of patterns. Around your throat, you've got your thyroid. A little further down around your sternum, you have your thymus gland, which is where your T cells, which are part of your immune system, help them learn to fight off disease. A little bit further down, on top of each kidney, you've got an adrenal gland. They make adrenaline and other assorted things. Around your stomach area, you've got the pancreas. And then on down, you've got either the testes or the ovaries. Hopefully not both, because that would be weird. All right, some other things we talked about is the endocrine glands are ductless. They make their hormones and put them straight where? To the blood, where they go where they need to go. What's sort of the opposite of an endocrine gland?
Exocrine.
Exocrine. What's an example of an exocrine gland? Sweat gland? Give me another one. Which organ is both endocrine and exocrine? Well, the pancreas. Because it makes things like insulin and glucagon that go straight into the blood, but it also makes digestive enzymes that go from the pancreas to where? The intestines, the small intestine in particular, and they get there through a tube, a duct. So it's both. Remember, though, that hormones help to maintain homeostasis. They control levels of all kinds of things in your body, like glucose and calcium, sodium, and so on. But they also help to control things like reproduction, growth, making of milk. They stimulate puberty and metamorphosis, all kinds of cool stuff. And the last time we talked about 2 glands, we'll talk a little bit more about those 2, and then we'll try to get maybe 2 more in today. We talked a little bit, first of all, though, about how that most hormones are either made of amino acid chains, short amino acid chains, or full-out proteins, which means their receptors are usually going to be found where? External, extracellular, right? But there are a few hormones, like estrogen and testosterone, are steroids. And they have internal, intracellular receptors. We talked a lot about negative feedback last time, and that's how most hormone levels are monitored and controlled. Let's go to this diagram first. Remember that the hypothalamus is like the boss. And if, let's say that your blood sugar levels are too low, what hormone do you need to be released? Blood sugar levels are too low. Glucagon. And what gland does that? The pancreas. So in my example, this would be the pancreas. And the hormone the pancreas is supposed to be releasing is glucagon. Well, before it starts to do that, the hypothalamus says, whoa, blood sugar's too low. I need to take care of that. But me being the boss, I'm not actually going to do any work. I'm going to tell somebody else to do the work. Because that's the way bosses work, right? So he sends out an order. It's called a releasing hormone. It's going to go to the anterior pituitary. It's going to say, okay, pituitary, got a blood sugar issue. I need you to take care of it. But the pituitary is also sort of like a boss, not the main boss, but the second in command boss. He's not going to do a whole lot of work either. He's going to tell somebody else to do it. So he sends out an order himself. It's called a stimulating hormone. And it goes out to the target gland, which in this case we're going to say the pancreas. And it says, pancreas, blood sugar is too low. You need to take care of it. Pancreas says, yes, sir. Releases glucagon. While that's going on, the hypothalamus is checking up to make sure everybody's doing their job, because that's what bosses do, right? And he's noticing that the levels of glucagon are going up. The pituitary is also checking to make sure the pancreas is doing his job. He's noticing that the levels of glucagon are going up. And when those levels get to a certain level, the right level, what does the hypothalamus do? He stops releasing this order. He stops giving off this order. And the pituitary stops giving off its order, which means the pancreas stops what? Making glucagon. Because it's back to where? Homeostasis. That's what negative feedback is all about. Get something back to homeostasis and then stop messing with it. Get it back to where it's supposed to be and stop. So that's negative feedback. We also talked a little bit about the pituitary and how that the pituitary is really two glands sort of rolled into one. It's the back and the front, the posterior and the anterior. Talked about how the posterior doesn't really make any hormones of its own, but it releases hormones that are made by the hypothalamus, puts them into the blood. There's two main ones you need to know. ADH, antidiuretic hormone, and oxytocin. And what do we say a diuretic was? It's something that makes you go, something that makes you urinate. So ADH reduces urine formation. And it does that by essentially telling the kidneys to reabsorb what? Reabsorb water. I take it out of the urine and put it back to where? Back in the blood. You're going to make a lot of ADH and release it when your body thinks it's dehydrating. So maybe you're running, sweating a lot. Maybe you just haven't drinking all the time. That's when your body tends to make ADH. It helps to keep you, it helps to do what's called osmoregulation, which is regulating the balance between water and what? Solids. Regulating the balance between water and solids. And then the other one that we mentioned was oxytocin. And this is the one that's released by the posterior pituitary, and it causes the uterus in a woman to contract. It helps to stimulate labor. It helps to push the baby out, essentially. It also helps to stimulate the woman to release the milk, not to make it, but to release it. And it's controlled by positive feedback instead of negative feedback. Which means the release of a little bit of it causes what? The release of more of it, which causes the release of more of it, which causes the release of more of it. I told you to think of this like a snowball going down a hill. That's the posterior pituitary. We also talked about the anterior, the front part, and how that it makes a whole category of hormones called tropic hormones. And these are hormones that are orders. They're hormones that control other glands. It also makes HGH, human growth hormone, and prolactin. And we will talk very briefly about each one of those. Start with HGH, and how that it stimulates your bones to get longer. It stimulates you to break down fat, and it stimulates you to make proteins and muscles. Too much of it can cause gigantism, these 8 feet tall people, and not enough of it can cause dwarfism. Or what else can cause dwarfism? Yeah, the receptor is actually messed up, because the receptor is a protein, which means it's coded for by DNA. And a little mutation in that DNA can cause the receptor to be the wrong way, the wrong shape, the wrong charge. One of those things can happen. And even though there's plenty of growth hormone there, it just doesn't work. Prolactin causes breastfeeding women to make milk. It also can cause men to make more testosterone. This whole column over here on the right, these are tropic hormones. Hormones that control other glands. For example, the ACTH stimulates the adrenal gland to make its hormones. TSH stands for thyroid stimulating hormone. Tells the thyroid to make its thyroid hormone. And then these two at the bottom are called gonadotropins, which means they control the gonads, the sex organs, the ovaries, the testes. And the two of those that we'll mention are FSH Anybody remember what we said the F stands for? Follicle stimulating hormone. And a follicle in this case is a cell that's either is or going to be a gamete. So it causes you to make gametes, FSH. And LH stands for luteinizing hormone. We'll talk more about what the lutein part of that refers to either today or next time. But it's the hormone that causes ovulation to happen in women about day 14 of the menstrual cycle. So this whole right-hand column are tropic hormones. Hormones made by the pituitary that help to regulate other glands in the body. Last time we also talked a little bit about the thyroid gland. So we'll hit it slightly today. Remember, the thyroid's around your adipose. It's right in that same neighborhood. The main hormone that it makes, you might hear called thyroid hormone. It's really made of two different chemicals, and those two chemicals are called thyroxine and triiodothyronine. Together, those two make it what's called thyroid hormone. Thyroxine and triiodothyronine. And the main thing you ought to know about that hormone, main thyroid hormone, is that it speeds up glucose metabolism, which essentially means it speeds up what? Cell respiration. It causes you to make more body heat. It causes you to make more ATP. So it's hugely important. It's one of the few hormones in your body that pretty much every cell has a receptor for. Because all cells have to do glucose metabolism. They have to go to make ATP. Just like anything, too much thyroid hormone is a bad thing. And we call that hyperthyroidism. And if you had hyperthyroidism, what would be some symptoms? You had too much thyroid hormone, what would be a symptom? Yeah, you're losing weight, you're hyper, you're just shaky all the time, you're bouncing around, your eyeballs sometimes will bulge out like they're about to explode out of your head. Hypothyroidism, on the other hand, you can gain weight really easy. You get really, really heavy. You can feel lethargic all the time, you don't have any energy. Either one's bad. One other thing I'll mention about that part of the thyroid, as far as scientists know, the thyroid is the only place in your body that you need what element? Iodine. And if you don't get it, if you don't have enough, what happens to your thyroid? It like swells up. It's a huge lump in your neck. And I heard somebody say that's called a goiter. I think we mentioned in here last time that you don't usually see that in the United States. What's the main reason why? Our salt has iodine artificially added to it to prevent this. Most places you see this would be in places like the heart of Africa. Why not on the coast of Africa? Yeah, all the salt water has a lot of iodine in it, so if you're eating seafood, you're going to get plenty of iodine. But if you're not, and you're living in the middle of Africa or the middle of Asia, you may not. Mention one other thing about the thyroid. It makes another hormone too. And that second hormone is called calcitonin. And notice what it says here. It says it regulates blood calcium and phosphate levels. So we're talking about like calcium ion levels, and what's the formula for phosphate in chemistry, people?
PO4, PO4,
PO4 minus 3. Both of those are really important where in your body? Calcium and phosphate. They're important in your bones. And if you look down here at the bottom of the slide, this hormone lowers both of these levels, the blood levels of both of these. And notice what it says. It lowers them by inhibiting osteoclast activity and stimulating osteoblast activity. What does that mean? What does osteo mean? Bone. So osteoclast There's cells inside your bones that break down your bones. If right now, those cells were very active, what would happen to your blood calcium and blood phosphorus levels? If you were breaking down bone, it'd go up, right? Because that calcium and phosphorus from the bones would get released into the blood. On the other hand, osteoblasts, guess what they do? They make new bone by taking calcium and phosphorus out of the blood. So essentially what we're saying is that this hormone calcitonin is telling you to make more bone. So it's really important in children. But for example, let's say that a pregnant woman is not getting any calcium in her diet. What's going to happen to that pregnant woman? Turns out the baby usually turns out okay. What happens to the pregnant woman?
Her bones.
To make the bones for the baby, her body starts to use these osteoclasts. They start breaking down her own bones. And her bones become really brittle, thin, her teeth may start to fall out. So essentially the baby is stealing calcium from her body to build its own body. It can cause your bones to break for no apparent reason, and like I said, teeth to fall out, all kinds of crazy things. So there's the thyroid, right around your Adam's apple, just below it usually. There's the goiter. Love those mutton chops. I'm thinking about growing some of those. I'm joking, by the way. Let's mention this one, the parathyroid glands. This is one you don't hear a whole lot about, so we're not going to spend a lot of time on it. What does para mean? Like paratrooper, paramedic, parathyroid. Almost, around, sort of, kind of like. Well, the parathyroids are called the parathyroids because guess where they're at? They're attached to the thyroid. They're attached to the back side of it, the posterior part. Like I said, they're just like 4 little dots. And like the thyroid, they help to control phosphate ion levels and calcium ion levels in your blood. It's their main job, to help to control phosphate and calcium ion levels. The main hormone they make is called parathyroid hormone. And notice what it says here. How that works is they stimulate the osteoclasts to break down bone, which should release more calcium, right? They also enhance absorption of calcium. Your intestines usually are not all that great at absorbing calcium. So you drink milk, where a lot of the calcium end up? In the toilet, okay? Not in you. So you're not very good at absorbing it. So it makes your intestinal cells better at absorbing it. It also causes you not to urinate it out very much. It takes it in from your urine, it puts it back into your blood. So you keep your calcium. There's all kinds of issues that can happen with your parathyroids. We're not going to worry too much about these two for right now. For right now, what I want you to know is it's also involved in helping to regulate calcium and phosphorus levels. If you know that, you know what you need to know about the parathyroids. There's one, maybe 2 other glands I really want to focus on today, though. And the main one here, we've already talked about, so we'll probably go through this one fairly quickly. Pancreas. Remember, the pancreas is right in the area of your stomach. It's both an endocrine and an exocrine gland. It's got 2 kinds of cells that we'll mention. In the pancreas are some cells that are called acinar cells. These are the exocrine cells. And what do we say that the pancreas makes that it sends out through a duct? Digestive enzymes And it also makes this stuff called the alkaline fluid. What's alkaline mean? Chemistry people, what's alkaline? Basic. Because what's coming into the first part of the intestine? Stomach acid, right? And the intestine is not really prepared to handle that. So to keep you from digesting your own intestine, the stomach is sending in acid at the same time the pancreas is sending in base. And when those two get together, what do you got? Acid plus base. You get neutral, right? So it neutralizes the stomach acid. The parts that we're going to be focused on today, though, are not the exocrine parts. We're going to focus on the endocrine parts. And those are called the islets of Langerhans. So your pancreas, that's not nearly the shape of the pancreas, but it might look a little bit like a body of water, like a lake or something. And then every now and then there's these bunches of cells that are the endocrine parts. All this blank space is the exocrine parts, but these little blue dots represent the endocrine parts. They look like little islands in a lake. And I'm assuming the guy who figured this out was Langerhans. So it's islets of Langerhans.
Why isn't it capitalized now?
It probably should be. Probably should be. The two hormones that we're going to worry about are the two that are listed up here, glucagon and insulin. The glucagon are made by cells in the pancreas called alpha cells. And remember that glucagon's job is to raise your blood sugar levels. And it can do that in a couple of ways. But the main way that we talked about many times in here is that glucagon tells the liver to break down glycogen and to release glucose into the blood. It can do a couple other things. It can also promote gluconeogenesis. Just look at that word. What would gluconeogenesis mean? Genesis actually doesn't mean beginning, it means creation of. Neo means new, gluco means glucose. So creation of new glucose. Can make your body make the glucose and then release it. And the other hormone from the pancreas we need to worry about is insulin. Insulin is made by cells called beta cells. And it's sort of the opposite of glucagon. A lot of hormones in your body occur in opposite pairs. Like these two. What's the word for opposite pairs of hormones? Because they do opposite things. Any idea? We're going to say that insulin and glucagon are antagonistic. Antagonistic pairs. They work against each other. But really, by working against each other, they're working for you, right? Keeping things in homeostasis. So insulin lowers blood sugar. And it can do that by causing oxidation of glucose, which means like the breakdown, right? It can cause the synthesis of glycogen. Remember, what's glycogen? Glucose, connected to glucose, connected to some more glucose, connected to some more glucose. It's a polysaccharide, right? It's just sticking them together. It can cause glucose to get converted into fat and lots of other stuff. But for right now, insulin lowers blood sugar levels, and let's just think of it by causing glucose to get converted into glycogen. And glucagon raises blood sugar by causing glycogen to get converted into glucose. Now everybody here knows something about diabetes. Turns out there's several different types of diabetes. The main one is diabetes mellitus. And these are some symptoms. Poor sugar usage. You can't handle the sugar that you eat. We may talk about ketone bodies later. Don't worry about those right now. What's polyuria mean? Polyuria. Just look at that word. What do you think it would mean? You got to urinate all the time. People who have diabetes have to go to the bathroom a lot. Polydipsia. Any idea what that might mean? It doesn't mean you need skull all the time, right? Polydipsia, that's not what that means. It means you're thirsty a lot. Polydipsia. And you ought to be able to figure out polyphagia. What would that mean? Hungry a lot. Metabolic acidosis. That would mean that your body fluids can become acidic. That's a bad thing, right? And it can make you go into a coma. It can also cause blindness. It can cause loss of limbs, like especially where your feet. Is it more on your left than your right?
Oh, I don't feel like I watched Scrubs and one of the characters had diabetes on there and they're talking about his left foot. So
I don't know if there's a left foot there, but feet tend to be first place to go.
Is it because I lost them?
Causes the circulation to get really bad. There's type 1 and type 2 diabetes mellitus. What's type 1? Type 1 is essentially, sometimes it's called childhood onset diabetes. Sometimes juvenile onset diabetes. Usually happens when you're young. And what actually causes it? Not 100% sure. But what they're thinking is it's probably an autoimmune disease. That it's your immune system attacking your pancreas and essentially destroying its ability to make insulin. So you don't make enough insulin. That's type 1. Do it now? Yeah. But with the treatment for that would have to be what? Insulin shots. If you're a type 1 diabetic, you're taking insulin shots. Or an insulin pump or something like that. Type 2, on the other hand, that usually happens when?
You're obese.
That usually happens when you're older and you're a little heavy. And it's not so much about maybe you're not making enough insulin, it's that your body has sort of become what to insulin? Tolerant to it. So you need more than you really ought to need for it to work. And there's drug treatments for this. If it's bad enough, they may put you on more insulin. But a lot of times there's different kinds of drugs they can use to treat this with. The first thing they're going to tell you is lose weight, stop eating sugary foods, stop drinking Coke, exercise. And most of the time that'll take care of it on itself. In a big part of cases, type 2 can be completely done away with by losing weight, exercising, and eating a better diet. But not always. Not always. I think this diagram does a really good job of explaining the pancreas and insulin and glucagon. Think of it like a seesaw, where here's the set point. So here's where we want to be. If we just ate, and let's say we ate something really sugary, our blood sugar levels went up. So the hypothalamus says, whoa, got to take care of that. Tells the pancreas to start releasing what? Insulin. So insulin goes out in the blood, travels to the liver, and it says, liver, take some of that glucose out of the blood, make it into a polysaccharide, make it into glycogen. It can tell the muscles to do the same thing. It can also tell the adipose tissue, which is just a fancy word for what? Fat, to take glucose out of the blood and make fat out of it, store it for later. The net effect on that, though, is going to be to push our seesaw back down, back to homeostasis. On the other hand, if it's been a while since you ate, your blood sugar levels start to dip. So the hypothalamus says, whoa, blood sugar's too low, pancreas take care of it. Pancreas releases glucagon. And the glucagon can go out to the liver, and it can tell it to take that glycogen and break it apart, put more glucose into the blood, or it can tell the fat to break down some of that fat and use it to manufacture glucose, to make it. Net effect there, raise the glucose levels back up to where they're supposed to be. So those two are antagonistic. They do opposite things, but they always help you to keep you near homeostasis. It's a negative feedback loop. All right, and the other one that we'll talk about today, a little bit about the two reproductive glands, the ovaries and the testes. And remember that the gonads produce steroidal hormones, the steroids. Turns out your adrenal glands can also make those. Do you ladies have testosterone? Small amount. But you don't have the typical testosterone-making parts, right? The adrenal glands can make a little testosterone for you guys, you ladies rather. And for us guys, we have a little bit of estrogen, and that's coming from our adrenal glands. But for right now, let's focus on the two main producing organs. Let's talk about the ovaries first. The ovaries make estrogen, and this is some of the function of estrogen. Stimulates the maturation of the sex organs and the secondary sex characteristics. What do we mean by secondary sex characteristics? What would that mean? Yeah, stuff that happens to a woman at puberty. Body hair growth, curviness, breast development. The things that happen to a woman at puberty, that's what we're talking about. It's also important, though, in regulating the menstrual cycle, in regulating bone health. When do women start having problems with their bones? After what? No. After menopause. It's what happens in menopause to your estrogen levels. They go way down. Before menopause, a man is, I forget how many times more likely to have a heart attack. Way more times. After menopause, who's more likely to have a heart attack? The woman. And who's more likely to die from a heart attack? The woman. Way more likely. Because us guys, our hearts are a lot bigger, a lot stronger. We can lose part of it, which is what a heart attack is, right? Part of it dies. And we can still be okay sometimes, because ours is bigger and it pumps harder. But you ladies, your heart's smaller, it doesn't pump quite as hard. You lose part of it, you're more likely to die. Also, women's risk of cancer goes way up after menopause, right? Estrogen is kind of a protective molecule for you ladies. Draven's thinking about just taking it after hearing this discussion. No. The ovaries also make another hormone, progesterone, which we'll talk about a little bit later. It too is involved in regulating the menstrual cycle and the reproductive cycle. We'll talk about those two. That's how we'll end today. We're talking about those two a little bit more. The testes, on the other hand, though, make testosterone. And sometimes you might hear the male sex hormones, which testosterone is probably the only one you'll ever hear about in this class, referred to as androgens. What's andro mean? Like android, for example. The word android, what does it mean? Oi means like. What's the andro part mean? Man. Man-like. So androgens are male sex hormones. Testosterone being the main one. When we hear people taking steroids, I don't think there are many people taking estrogen for the heck of it, right? They're taking testosterone to make muscle, lose body fat, those kinds of things. Testosterone causes the maturation of the sex organs. It causes the secondary sex characteristics in men. Deeper voice, more body hair, facial hair, muscle growth. The typical things that happen to a guy in puberty. Also is involved in the sex drive, and it causes the body to make sperm. All those things happen because of testosterone. Now, there's a lot of doctors now that are prescribing testosterone for older guys, right? You can get it like in almost like a deodorant container, where it's like rub-on. There's been some weird things that happen with that, because occasionally, what will happen? They put it under their arm or somewhere like that, and maybe they have a small child and play roughhousing with a kid, maybe it's a little girl, and some of that testosterone gets on the girl's skin, and it can cause weird like body hair issues, it can cause early menstruation, it can cause all kinds of strange things. Even if a grown female was to come into contact with very much that, it can cause some weird things to happen. So you're going to use that kind of gel-like testosterone, you got to put it in a place that nobody's going to come into contact with. Because you don't want a woman to be absorbing all this testosterone. That's not good. Or even a young boy, you don't want him absorbing it either, right? He hasn't hit puberty yet.
You don't want a 9-year-old with a beard.
Yeah, right.
Then putting it on, does that not cause him to like grow more hair?
Well, it absorbs into the blood, so no, it might cause it to grow faster. What we're looking at here are hormone levels in a woman. And I think I've got a better diagram on the next slide. Let's look at this one. Let's start out by talking about some stuff at the bottom. Very bottom diagram. It says it's the endometrial histology. What is that? Endometrial histology.
Science of...
What's histology mean? In this class, whenever you see histo, like in class today, we talked about the major histocompatibility complex, the MHC proteins. That means tissue. What is the endometrium? You ladies have this, so you ought to know what it is. You guys, I'll give you a pass because you don't have it. You know?
What are we guessing?
It has something to do with the uterus. What's the endometrium? It's the lining of the uterus. The endometrium, the lining of the uterus. What happens to that every month? It gets thick, its blood vessels growing in it, and then it peels off and comes out. Starts over. Every month. That's the endometrium. So that's what we're looking at down here in the bottom. What's going on with endometrium? And then in the middle, we're looking at hormone levels. Talk about those in a second. A little bit further up, we're looking at body temperature. And a little bit further up, we're looking at what's going on in the ovary. So let's start off by looking at the endometrium here for a second. So what happens at day 1 of the cycle, of the menstrual cycle? How do you know you're at day 1 of the cycle? That's when the bleeding starts. It's day 1. And that's happening because what's happening to the endometrium? It is coming out. It's peeling off. And notice, from about day 1 to about day 6 or 7, you can see it peeling away, coming off, and it's going away. But notice at about day 8 or so, what starts to happen? It starts to grow back. It gets thicker. And what do you think these little lines running through there are? Well, it's probably not very visible from where you're at. There's little lines going up through here. What do you think those little lines are supposed to be? Blood vessels. It's becoming really vascularized. It's getting a lot of blood vessels in it. And notice that it peaks out about day 25, 26. It gets its thickest. Well, let's talk about what causes that to happen. Let's look at the hormones. Look at your, well, actually before we get to the hormones, let's look up here at the egg for a second. At the top. So we start off with follicles. Follicles are essentially the egg in a container surrounded by some cells. Notice they start off really small. At day 1, they're really, really tiny egg cell and a tiny follicle. But as you go from about day 1 to about day 7 or 8, that thing starts to swell up. What's the blue stuff? It's basically water. It's fluid. It starts to swell. Continues to swell and swell until you get to about day 14. What happens to that follicle? It pops like a zit. And that's kind of how I want you to think of it. Because where's this follicle at? Something, not the uterus.
I mean, wherever it
You don't know much about women,
is. Ovary.
It's on the surface of the ovary. And it's swelling out like a zit. Popping out. Until eventually it explodes. And out shoots what? Out shoots the egg. Headed toward where? Where should it be heading? The fallopian tube, which will then take it to the uterus. But part of that follicle is left behind in the ovary. And the part that's left behind is called the corpus luteum. It's the left behind part of the follicle. and it becomes a hormone-making factory. It makes lots of hormones related to baby making. And we'll talk about it in a second. But remember, corpus luteum is the left behind part of the follicle. It stays in the ovary. Egg comes out, heads toward the fallopian tube. Corpus luteum is left behind. So if you look, let's look at your hormone levels now. Day one, all your hormone levels start off fairly low. The blue line, it says estradiol, that's essentially estrogen. The green line is luteinizing hormone, LH. The black line is progesterone. And the red line is follicle stimulating hormone, that's FSH. So notice all the levels start out low. But as you start progressing through the cycle, say somewhere around day 8 or 9, the estrogen levels start to go up. What do you think those estrogen levels are causing to happen? What's following this pattern of estrogen? So estrogen goes up, endometrium lining gets thicker. So this is causing this. Continues to peak, keeps going up until about day 14 or so, where it peaks out. Also notice that the levels of LH and FSH peak out about day 13 or 14. FSH is causing this follicle to grow. What does the F stand for? Follicle stimulating. It's making it grow. LH, remember, stands for luteinizing hormone. Now you might understand why it's called that. Because what does it cause to happen? It causes the egg to pop out, meaning what is now there? Corpus luteum. That's what's called luteinizing hormone. It causes the corpus luteum to be formed. Those both drop back down quickly to where they're supposed to be. Also notice that around day 12 or 13, the progesterone levels start to go up. And those are really important for making the endometrium get really thick. That's the main thickening hormone, is the progesterone. All right. Let's say that, really, you can only get pregnant when in this cycle, if you're a woman. You've got to be within a day or two of 14. So somewhere in there is the time the pregnancy could take place, somewhere in that small window. Remember, this is the typical woman. Is every woman following this like a calendar? No, some women are different. Some women are on a different time schedule, right? But most women are similar to this. So somewhere in that neighborhood is where pregnancy could occur. If it doesn't occur, what happens to this corpus luteum if there's no fertilization? It just starts dying away and it degenerates. Remember, this corpus luteum is the part of the body that's making the progesterone. So if it dies away, what happens to the progesterone levels? They drop. If the progesterone levels drop, what happens to the endometrium? It starts to die, flake off. So if there's no fertilization, corpus luteum degenerates, progesterone levels drop, endometrium starts to slough off, it starts to fill off. If, on the other hand, fertilization does happen, what happens to the corpus luteum? It just keeps on pumping out progesterone. It doesn't degenerate. And if it doesn't degenerate, what happens to the endometrium? It stays thick because the progesterone levels, instead of doing what we see in our graph, they're going to do more like that. They're going to stay constant. And that helps to keep the endometrium there, which will accept the egg and nourish the egg, and all the stuff that's supposed to grow will grow there, like the placenta and the umbilical cord and all those kinds of things.
While that's happening, does the line still keep getting bigger?
It eventually it'll max out, and it'll just sort of stay there. Helps to keep it at that level. One way a lot of women know they're ovulating is by checking their body temperature. At about day 13, day 14 of the cycle, the body temperature goes up almost a degree. And that's one way women who are trying to get pregnant can check their ovulation cycle, is by measuring their body temperature. We'll stop there for today. We'll pick back up here next time and go through some of that again. Got about 2 more glands we want to talk about, and we will be finished with the endocrine system.